So yeah, in today's session, we are going to talk about some more advanced concepts related to counting. At the end of last session, we talked about permutation and combination, the basics that is. And today we are going to talk about more advanced ideas of permutation and combination, that is applying them for generic cases and using the formulas for special scenarios of permutation, combination, these things. So if you guys remember, counting R permutations from n distinct objects, how did we do that previously? What formula did we use to count the total number of R permutations from n distinct objects?
n factorial
That's
divided by
correct,
n
n
minus r
factorial
factorial.
divided by n minus r factorial. Now, the conditions there were that n would have to be distinct, that is, n would have to be comprised of all distinct objects, and that the choice that you make for R would be distinct as well. That is, say for example, if you have a set that contains 6 objects, yeah? It contains 6 objects and you have to count 2 permutations from these 6 objects. So previously, what would be the scenario? For the first choice, the object that you pick, you could not pick that object again for the second choice, all right? That is, the objects that you picked for the 2 permutations, they would have to be distinct, not repeatable, basically. You cannot repeat a choice, right? That was the previous condition. What if they said that repetitions are allowed? That is, the choice that you make, you can repeat that choice. What if they say that repetitions are allowed? What would we do then? In that case, the choice of object for your first choice, that is, you have to count 2 permutations, right? For the first one, whichever object you pick, you can choose that again. It's possible to choose that again for the next option, right? What if that happens? Can we use the same formula in factorial by n minus r factorial? That formula was built on the basis that you cannot pick a certain object more than once, right? So remember, we had n options, and then for the first object, for the second one, we had n minus 1, for the third one, we had n minus 2, and so on. But this time, they're saying that repetitions are allowed. If repetitions are allowed, would we use the same formula? Would the same formula be applicable?
Miss, didn't we do this in combination? Like, it doesn't matter order or doesn't matter. So we can repeat.
No. In case of combination order doesn't matter. Yeah, sure. But still, in case of combination, we didn't count repetition, remember?
Okay.
Permutation, combination, the basics that we've studied so far, in both cases, in case of permutation, order matters. In case of combination, order doesn't matter. However, in both cases, we were counting from n distinct objects and we were counting distinct objects as well, right? The choices that we made were all distinct. Okay, so no. In case of combination as well, we got to that point by counting distinct things. Okay, the choices were distinct as well. So yeah, you can refer back to the previous session recording for that maybe. But my question now is that if they say that you have to count R permutations from n distinct objects where the choices are repeatable, where the objects are repeatable. In this R permutation, when you choose an object from the set, the choice is repeatable or the object is repeatable. In that case, would we use the same formula? No, we wouldn't, because the original formula that we have was for the basic case where we assume that both the n number of objects are distinct and the R number of choices you make are also distinct. Okay? Here, we're saying that a choice is repeatable. In that case, what will we do? Think about the case of a set having 6 objects and you have to count 2 permutations. For the first choice, you have 6 objects to pick from. For the second choice, how many objects do you have to pick from?
6. Miss, product rule.
Exactly, very good. Product rule. So what would it be? 6 square, right?
Yes, miss.
So basically, the number of objects that you have in the set n distinct objects, and the number of permutations that you're counting. I mean, like, we're trying to count a total number of R permutations, right? So if the choices are repeatable, if you want to count the total number of R permutations from a set with n distinct objects where repetition is allowed, it would be n to the power of R. Make sense, guys?
Yes, miss.
Okay, good. All right. So we will look similarly, just like this, we'll look at special cases today. What happens when the conditions for permutation and combination, the basic conditions, are tweaked with. So we'll use the same idea. And remember the thing about bit string. Remember that towards the end of the class, we established a method of counting the total number of bit strings of length n containing exactly R1s. It was CNR. Remember, guys? The total number of bit strings of length n, which are n length long, that contain exactly R number of ones, is CNR. We established this at the end of the session.
Yes, ma'am.
Yeah. If you're a bit hazy on the explanation, you can go back to you can revisit the previous recording later on after the class maybe, and then get clear on that. I'm not going to go over the explanation again, obviously, but we will use this idea that we got from the basic concept of permutation and combination. We will use this idea to solve other more complex or special cases, okay? For example, counting the total number of non-negative integer solutions to such an equation. All right. Here, as you can see, we have n number of x's on the left-hand side, and the summation of all these x's would be equivalent to R. So you'd have, this is a general format, basically, for any equation where you have a constant on the right-hand side, a positive constant, a non-negative constant on the right-hand side, and on the left-hand side, you have n number of x's, all right? And the summation of all these x's, we don't know the values of x's yet, all right? We don't know the values of x's. But the summation of all of these x's should give us R. So if you have such an equation, how many possible solutions are there? We want to count the total number of non-negative integer solutions, where x1, x2, x3, and so on until xn, all of the x's will have a value greater than or equal to 0. That is, there will be non-negative. So non-negative integer solutions to such an equation, how many non-negative integer solutions to such an equation would there be? Okay, so we want to count that. So first, let's establish clearly what it means. So this is the format, right? This is an example of such an equation, all right? So R would be some constant on the right-hand side, and on the left-hand side, you have x1, that is n number of x's. Here we have 4 x's. So we have to come up with, we have to count the total number of non-negative integer solutions to such an equation, all right? What is one possible solution to this equation? 2, 2, 2, 0. X1 is equal to 2, x2 is equal to 2, x3 is equal to 2, x4 equal to 0. Gives us what? 2 plus 2 plus 2 plus 0. Gives us 6. So that is one possible solution, all right? Another possible solution is what? 1, 1, 1, 3, okay? x1 is equal to 1, x2 is equal to 1, x3 is equal to 1, x4 is equal to 3. The summation of these gives us what? 6 again. So that is another possible solution. Can you guys give an example of a solution?
Yes, miss. 0006.
Yeah, very good. Yeah. So you understand what we mean by this general equation. So what we want to do is not come up with the solution. We want to count the total number of possible solutions to such an equation. Right? So how can we do that? So what we will do here is actually, remember again right at the start we said that in discrete mathematics, what we do is we try to count things. We try to solve problems by counting things. And when we do that, to make our lives easier, instead of finding unique solutions to each different problem, we will try to associate a problem with another problem. Try to find similarities between seemingly different problems which seem different in the first glance. We'll try to establish similarities between them. And then what you'll see is that the method of solving one problem gives us the solution of the other problem as well. Once we establish the similarity, it will be clear. So here, for example, we have to count the total number of non-negative integer solutions to this equation. The total number of non-negative integer solutions. যতগুলো solution possible, non-negative integer, for this equation, we'll count all of them. So in order to do that, what we will do is, we will establish each of the solution using bit strings. Okay. So for example, look at the demonstration here. 1, 2, 2, 1. x1 is equal to 1, x2 is equal to 2, x3 is equal to 2, x4 is equal to 1. Is that a possible solution for this equation, guys?
Yes, miss.
Yes, it is. So what we will do is represent that in terms of bit strings. How so? So for the first value, x1 is equal to 1, to represent this one, we will use a single 0. Since x1 is equal to 1, we used 1 0 here, a single 0 here. And then before moving on to the next value, we will use a partition to separate the two values. To separate the two values, we'll use a partition of 1. We'll use the partition with 1. So 1 is the partition. Then to represent x2 is equal to 2, we will use 2 zeros, all right? Since x2 is equal to 2 here, we will use 2 zeros. Okay, and then another partition, x3 is equal to 2. So how many zeros will we use again? 2 zeros, since x3 is equal to 2. So 2 zeros again. And then before moving on to the next value, again another partition. So this partition, another partition. Now finally, x4 is equal to 1. Again, since x4 is equal to 1, a single 0 to represent that. So this bit string represents this specific solution. Then another possible solution is this. x1 is equal to 2, x2 is equal to 3, x3 is equal to 1, and x4 is equal to 0. This also gives us 6 for this equation. So this is another possible solution. So how do we represent this? In order to represent the x1 is equal to 2, we will use 2 zeros. First is x1 is equal to 2. So we'll represent that again using 2 zeros. Then before moving on to the next value, again another partition using 1. And then x2 is equal to 3. Since x2 is equal to 3, we will use 3 zeros this time to represent 3 zeros. And then another partition. And then x3 is equal to 1. For that, a single 0. Finally, another partition before moving on to the next value, obviously. x3 is equal to 1, so single 0. But before you move on to the next value, you need a partition of 1. Fine. But x4 is equal to 0. Since x4 is equal to 0, we will not have any 0 here at all. Okay? So for 3, we had 3 zeros. For 2, for the solution 2, we had 2 zeros. For the solution of 1, we had a single 0. For 0, we will not have any zeros. Since there are no zeros, after the last one, we can assume from this that x4 was equal to 0. Okay, first 2 zeros. There are 2 zeros here. Okay, x1 must be equal to 2. Then a partition. Okay, then we're moving on to x2. Then 3 zeros. So x2 must be equal to 3. Okay, a partition. Then we move on to x3. Okay, single 0. Then x3 must be equal to 1. Okay, then a partition. And then nothing. That means x4 must have been equal to 0. Okay. And similarly, this one. x1 is equal to 1. So a single 0 here. And then before moving on to the next value, you put a partition. x2 is equal to 3. So 3 zeros here. And then x3 is equal to 0. So what do we have here? Nothing. After the last partition, you do not put any zeros because x3 is equal to 0. So because of the first 0, we know that there's a single 0 here, x1 is equal to 1. There are 3 zeros here, x2 must be equal to 3. Here, there are no zeros between these two partitions. It must mean that x3 is equal to 0. And then finally, x4 is equal to 2, so 2 zeros here. Okay.
Miss.
Yeah.
Why do you have another 1? Because we already created a partition with 1.
Yeah, but if you didn't have another one, how would you be able to tell that which one is 0, which one is 2? Okay. I mean, A1 ta jodi na thakto, if you had 0, 1, 3 zeros, then 1, and then 2 zeros. x3 এর value কি, x4 value কি? কোনটার value 2, কোনটার value 0? How would you be able to tell? এটা তো বলার কোনো way নাই then. So for that reason, you need the partition. So 1 এর পরে আবার 1 আছে. It means what? এখানে কোনো আমি 0 place করি নাই। তার মানে কি x3 is equal to 0. And then finally last এ দুটা 0. তাহলে last j, x4 j, the last one, x4 must be equal to 2. Is that clear?
Yes, miss.
Okay. So do we understand the association between the possible solutions and the bit strings?
Yes, miss.
Okay. So in
Yes,
that
but
case,
it is only applicable for tuples.
sorry?
Yes, is this only applicable for tuples?
Well, yeah, I mean, but aren't tuples enough to represent all the solutions of this equation? I mean, what else would you use other than tuples?
Yes, I was just saying in general, because if we just want to state like 1 and 2, then are we gonna write like 0, 1, 0, 0?
Come again? If you
Yes,
just use what again?
if we want to say 1, 2, that is like 12, then what we are gonna write, like 0, 1, 0, 0.
No, 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 no. The number 12. No, it's not like that.
Yes.
No, 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 no. These are here on the left-hand side. The tuples represent what? The tuples have a specific significance. The tuples represent the possible solutions to this equation. In order to represent the possible solutions to this equation, we are using the tuples. All right, and tuples are ordered, as you can remember. So
Yes.
1, 2, 2, 1 has a specific significance. It means that x1 is equal to 1, x2 is equal to 2, x3 is equal to 2, x4 is equal, sorry, x3 is equal to 2, x4 is equal to 1. Okay?
Okay, miss.
So the tuples have a significance. And yeah, we are using the tuples and the tuples only to represent this bit string. Okay?
Okay,
All right.
miss.
Okay. But is that clear that for such an equation, you can represent the possible solutions using bit strings? If you understand that, then tell
Yes,
me
miss.
2220, this tuple, that is x1 is equal to 2, x2 is equal to 2, x3 is equal to 2, x4 is equal to 0. That's a possible solution, right?
Yes, miss.
How would we represent that using bit strings?
0, 0, 1, 0, 0, 1, 0, 0, 1, and then 1.
Yes, that's correct. So 0, 0, 1 for the first two, and then 0, 0, 1 for the x3 is equal to 2, then 0, 0, 1 again for x3 is equal to 2, and then just another one because x4 is equal to 0. That's correct. Does everybody understand this?
Yes, ma'am.
Okay, now that we get it, notice something. Each of the bit strings contain how many ones?
3 ones.
3 ones.
3.
Ones. That also has a significance. Why? Because how many x's do we have here? 4. So to separate the value of each of these x's, প্রত্যেকটা distinguish করতে পারার জন্য, in order to be able to distinguish between these 4 x's, how many partitions do we need? 1, 2, 3. We will need 3 partitions to separate between 4 different values. Yeah, 4টা different value মধ্যে partition create করার জন্য we need 3 partitions. And if you have 4 x's, it will always be 3 partition. And for 3 partitions here in the bit string, you will always have 3 ones. Right? So you will always have 3 ones to represent the partition between the zeros, which represent the value of x1, x2, x3, x4. Does it make sense, guys?
Yes, miss.
4 x's will always have 3 ones because 4টা x partition কয়টা থাকতে হবে তাহলে 3টা 4টা ভ্যালুর মধ্যে 3টা partition লাগবে. So there'll always be the number of ones in these bit strings representing the solution will always be exactly 3. You will always have exactly 3 ones in all of these bit strings which represent the solution of this equation. Okay. All right. So we have, in the general case, we have n number of x's, right? Here n is equal to 4. So basically what we can say is that the total number of ones in these bit strings which represent the solution, the total number of ones will be n minus 1. Okay. So if you have n number of x's, basically, n can be any number. Here n is equal to 4. In this example, n is equal to 4. So if you have any number of x's, n, in that case, how many partitions would you need? N minus 1. Think about it. যদি এটার জায়গায় থাকতো x1 plus x2 plus x3 is equal to 6. How many partitions would you need? 2. 3 minus 1, 2. For x1, x2, x3, x4, x5. 5টা x থাকলে কয়টা partition লাগতো?
4.
To distinguish between the 5, 4, exactly. 5 minus 1, 4. So for n number of x's, the total number of partitions you would need to distinguish between the values of x's would be n minus 1. Okay? And the zeros, the total number of zeros, what would that be equivalent to? What do you guys think? In this case, the total number of zeros, for this specific example, the total number of zeros in all bit strings which represent the solution would be equivalent to what?
6.
6, exactly. Because the zeros represent the values of x1, x2, x3, x4 themselves, right? So
Yes,
the total number of all zeros would always be equal to 6. So here, see what we are doing. We are representing all possible solutions of this equation using bit strings which have exactly n minus 1, that is 4 minus 1 is equal to 3 ones and 6 zeros. Okay? All solutions of this equation can be represented using bit strings which have 6 zeros and n minus 1, that is 4 minus 1 is equal to 3 ones. So 6 zeros and 3 ones. Does that make sense, guys?
Yes, miss.
Yes.
Yeah. So if that's possible, if you understand that it's possible to do that, in that case, what about the generic situation? If you have n number of x's and here you have r, in that case, can you not represent the solution of any equation which follows this format using n minus 1 number of ones in the bit string and r number of zeros? It basically means that, right? You would have r number of zeros and n minus 1 number of ones in the bit string, right?
Yes, miss.
Yes.
So total r number of zeros and total n minus 1 number of ones. What would be the length of these bit strings, guys?
Miss, R plus
N
n
minus 1 plus R.
R plus n minus 1. Very good. R plus n minus 1 or n plus r minus 1. All right. So the length of these bit strings would be n plus r minus 1. So let's go back to our previous lecture just a bit. So we already established, remember, that the total number of bit strings, all bit strings in the world, which are of length n, that is, they have total number of n bits in them and contain exactly r number of ones, is CNR or NCR. The total number of bit strings of length n that contain exactly r number of ones is NCR. We established this. Now, in our problem here, the bit string, the length of the bit string is n plus r minus 1. The length of the bit string is n plus r minus 1, and the number of ones is exactly what? N minus 1. Yeah. So the length is now n plus r minus 1, and the total number of ones is n minus 1. So what would we have here? How can we use combination to count all the bit strings which follows this format?
Miss, n plus r minus 1, C r n minus 1.
N plus r minus 1, C, n minus 1, right?
Yes. Yes, miss.
N plus r minus 1, C, n minus 1. Yes, that's correct. N plus r minus 1, C, n minus 1. Let's just count all the bit strings of length n plus r minus 1, which contain exactly n minus 1 number of ones. Okay? That gives us all such bit strings. And all of these bit strings represent the solution of the equation, the non-negative integer solutions of the equation. So basically, to count all possible non-negative integer solutions to this equation, first we established an association between the non-negative integer solutions and bit strings. And then, since we know already how to count bit strings that contain exactly a certain number of ones, since we already know this, we applied this idea there. Okay, you see how we did that. So if you want to count the total number of non-negative integers solutions for the given equation, you can use just this formula, right? So here, for example, here, n is equal to 4, r is equal to what? 6. N is equal to 4, r is equal to 6. So the total number of non-negative integer solutions for this equation would be equal to what? N plus r minus 1 which is 9.
9C3.
Plus 6 minus 1. Exactly. 9C what?
3.
9C3. Correct. 9C3. I will tell you that 9C3, while it's correct, 9C6 is also correct. That is, instead of counting the total number of bit strings which are of this certain length and contain exactly 3 ones, you can count instead the bit strings which contain exactly 6 zeros. It's the same thing, all right? Because if they contain exactly 6 zeros, then the other 3 must be ones. Or in other words, if they contain exactly 3 ones, then the other 6 must be zeros, right?
Yes, miss.
The string is either one of these two. So basically, n plus r minus 1, c, n minus 1 is equivalent to n plus r minus 1, c, r. Okay? So yeah, if you want to count the total number of non-negative integer solutions for such an equation, you can do that by applying this formula or that formula. This is just the explanation, the proof written down based on all the stuff that we've discussed so far. But does everyone get it? That it's possible to count the total number of non-negative integer solutions to such an equation using either one of these two formulas. And how we got here. Is that clear? It's important that you understand this because you will also be expected to prove things in this format, all right? First, establish a connection between the given problem and a problem that you already know about. Here, what did we do? We established a connection between this problem and bit string, all right? We already know how to count bit strings with exactly a certain number of ones or a certain number of zeros. We already know that. We just applied that idea here by establishing first the association between this and this. The solutions of this equation with bit strings, we established that association first and then used the method of counting bit strings here to count the total number of solutions of this equation. So that's what gave us these two formulas. Is this clear, guys?
Miss, I have a question.
Yeah, go ahead.
Miss, like in bit strings, the previous examples we did, like for in product rule, in bit strings, we didn't use partition. Are there any like other ways of using bit strings than partition?
Here, we're using the partition to separate the specific values. So yeah, you can use bit strings for other purposes as well. There are many cases where bit strings are used to solve a problem. But for this, if you're talking about specific problem, in this case, yeah, the way to do this is using partitions, yeah?
Yes, miss.
So yeah, because see, think about it. I mean, like we want to separate between these values, yeah? We want to be able to distinguish each of these values. So we need the partition. So yeah. Is that what you were asking?
Yes, miss.
Yeah. Okay. So here you must use the partition. The partitions is absolutely necessary because you need to distinguish between these values. All right. So mean like এই চারটা ভ্যালুর মধ্যে to distinguish করতে পারতে হবে because when like x1, x2, x3, x4, all the different values of these make up the solutions. Okay. So if you can't distinguish between these, then how can you come up with the solution? So obviously you need the partition. And hence we get here with these formulas. Any questions, guys? Any questions or confusions regarding how we got here or how we established the correlation between the solutions of this and bit strings and then how we got here basically? Any questions? Okay, good. In that case, let's try to solve this problem. It's very straightforward. Simply, we have to count the total number of non-negative integer solutions for this equation. We already know that, how to do that. So if you have n number of x's and r on the right-hand side, then we just simply have to apply this formula, which we already proved how we got here, okay? So here, how many x's do we have, guys?
3.
So what would be n? N would be equal to what?
2.
N would be equal to 2.
No, miss, n is 3. N minus 1 is 3.
N is 3.
Oh, n
Remember
minus
when we do the, yeah, n minus 1 is 2. So n is 3. Remember we do the decrement later on. But first, n is equal to 3. Don't get that confused, okay? N is equal to 3. And what
Yes.
is r?
11.
11.
11, exactly. So we have the formula already, n plus r minus 1, c n minus 1. So 3 plus 11 minus 1 gives us 13, and minus 1 gives us 2. So 13c2. Another thing that you could do is 13c11. It will give you the same result. Yeah? And it's
Yes,
the
yes.
same thing. Okay.
But you didn't give easy questions like this.
Yeah, we go with trickier questions. For example, what if we put more conditions here? Here, for example, all we need to do is count non-negative integer solutions. That is, solutions where all these three are just simply non-negative integers. Simply non-negative integers. Non-negative integer mane ki? x1, x2, x3 has to be greater than or equal to 0. Right?
Yes, miss.
What if we put more conditions on top of that? What if we said that x1 has to be greater than or equal to 1, x2 has to be greater than or equal to 2, x3 has to be greater than or equal to 3. What if we did that? In that case, what would you do? Now, this is not a simple case of counting all possible non-negative integer solutions. No. Here, x1, x2, x3, they simply will be non-negative integers. You cannot say that. x1 has to be greater than or equal to 1. More conditions. x2 has to be greater than or equal to 2. x3 has to be greater than or equal to 3. So how would you count the non-negative integer solutions? Sorry, how would you count the integer solutions of this equation? How? Because the previous cases are for the solutions where all solutions simply have to be non-negative, that's all. But here we have added conditions. What we will do is we will transform this equation into an equation that we are familiar with. আমরা এই ফর্মুলাটা apply করতে পারি কোন equation-এ? যে equation-এ all the variables are simply non-negative and that's it. That is an equation we are comfortable with. That is an equation we are familiar with. We will transform this equation into that equation. All right? Since we cannot apply the formula directly in this equation, we will force this equation to go our way. Okay? The equation that we are familiar with. How will we do that? See, we are taking 3 more variables, y1, y2, y3, where y1, y2, y3 are simply non-negative integers. That's all. y1, y2, y3 are simply non-negative integers. In that case, what is the lowest value that y1 could have?
1.
Non-negative.
Yes, miss. 1.
0,
The
miss.
lowest value y1 could have is 0. Remember, y1, y2, y3 are simply non-negative. While 0 is not positive, 0 is still non-negative. Circle back to lecture 1 or 2 or whatever. All right? So y1, the lowest value that y1 could have is 0. Make sense, guys?
Yes, miss.
y1, y2, y3, since they're non-negative variables that we picked, y1, y2, y3, each of these, the lowest value they could have is 0. Now, if the lowest value of y1 could be 0, and we are representing y1 with x1 minus 1, y1 is equal to x1 minus 1. We pick some variable y1 where y1 is equal to x1 minus 1. Okay? A same equation take x1. If we want to find out x1 from y1, what would we have to do?
Miss, x1 is subject
X1
variable.
x1 is equal to what? মানে এখান থেকে এই ইকুয়েশন থেকে y1 বের করতে হলে y1 is equal to x1 minus 1. x1 কে বের করতে হলে what would this equation be?
y1 plus 1.
Yes, exactly. x1 is equal to y1 plus 1. All right? So x1 is equal to y1 plus 1. If the lowest possible value of y1 is 0, in this equation, what is the lowest possible value of x1?
1.
1, exactly. So does it agree with our condition? Yes, it does. So since x1 is greater than or equal to 1, we use a new variable y1, which will be equal to x1 minus 1, where y1 is a non-negative integer, and hence x1 will always be greater than or equal to 1 if we use this y1. And then we'll take another variable y2, which is equal to x2 minus 2. Here again, the lowest possible value of y2 is 0. The lowest possible value of x2 will be what?
2.
2. y2 plus 2. So y2 lowest value is 0 hoy, 0 plus 2. x2 lowest value will be 2. So see, again, it's agreeing with our condition. Since x2 has to be greater than or equal to 2. Because of this, we use a new variable y2 is equal to x2 minus 2. Similarly, for x3 greater than or equal to 3, what will we do? We'll use a new variable y3, which will be equal to x3 minus 3. So by using these three new variables, y1, y2, y3, which are simply non-negative integers, by the way, we can represent x1, x2, x3. All right? X1 minus 1, x2 minus 2, x3 minus 3, respectively. And they will agree with the condition. So far, is it clear with everyone? Because of these conditions, we are using these variables, new variables, y1, y2, y3. Each of these are non-negative integers. Remember, what do we want to do? আমরা কি করতে চাচ্ছি? আমরা এই ইকুয়েশনকে ট্রান্সফর্ম করতে চাচ্ছি to an equation where we can apply our formula. What is the difference here? এই ইকুয়েশন আর ওই ইকুয়েশনের মধ্যে ডিফারেন্সটা কোথায়? That equation, the previous equation, here is for simply non-negative integers. This equation has more conditions. So what do we have to do? Transform the variables into variables which are simply non-negative integers. That's all. So y1, y2, y3, we pick these three variables to be non-negative integers. We want to transform this equation into an equation which is only for non-negative integer solutions. So we now pick y1, y2, y3, where each of these are simply non-negative integers. And y1, y2, y3 will be equal to x1 minus 1, x2 minus 2, x3 minus 3, respectively. Why? Because of these conditions. Because we have represented y1, y2, y3 in terms of x1, x2, x3 in this way, these conditions are not violated. Does it make sense so far, guys? Okay.
Yes, ma'am.
Are there any questions or confusions with anyone? All right. If you get that, then that's good. So now that we have this, what can we do? We can just replace the x1s. We can just replace the x's, x1, x2, x3, with the y's. How? x1 is equal to what? y1 plus 1. So put y1 plus 1 here. x2 is equal to what? y2 plus 2. So put y2 plus 2 here. x3 is equal to what? y3 plus 3. So put y3 plus 3 here. So what do you get? y1 plus 1 plus y2 plus 2 plus y3 plus 3 is equal to 11. That is y1 plus y2 plus y3 plus what? 1 plus 2 plus 3 is equal to 11. 1 plus 2 plus 3 is what? 6. So y1 plus y2 plus y3 plus 6 equals to 11, gives you y1 plus y2 plus y3 is equal to 11 minus 6, which is 5. So see, this equation is equivalent to this equation. They are the same equations. They are now the same equations. Okay. We took care of these conditions by adjusting the value on the right-hand side. So this equation is equivalent to this equation. Now, the new equation that we have, which is equivalent to this one, in this equation, the only restriction on the y's is what? That they are non-negative. Now, that fits our definition. That fits our definition of the formula. In this new equation, all the y's are simply non-negative integers. Okay, so in this equation, from this equation, we simply have to find non-negative integer solutions. Now we have an equation in our hand where we can apply our formula, right? So here for this equation, n is equal to 3, r is equal to 5. So n plus r minus 1 is 3 plus 5 minus 1, which gives us 7. And n minus 1, which is 3 minus 1, gives us 2. Or so 7c2. Or in other words, you can also do 7c5. That is 3 plus 5 minus 1 and then r, which is 5. So 7c2 or 7c5 gives you the result of this. Guys, any questions or confusion?
No, miss.
Okay. I hope that's the same case for the rest of you guys. If you have any question or confusion, please go ahead and ask. It's fine. All right, I'll go over it again. So yeah, if you guys all understand this, then we can move on to another example, okay? So let's say there are 4 different types of cookies in a cookie shop, right? A cookie shop has 4 different types of cookies. You have to choose 6 cookies, okay? You have to go to this cookie shop and buy 6 cookies. We have to find out, what we have to do now is find out how many ways are there to choose these 6 cookies from the 4 options, okay? Remember that the cookie shop has 4 different types of cookies, okay? You go to the cookie shop and buy 6 cookies. We have to find out how many ways are there to get these 6 cookies from the 4 different options, okay? So think about it, 4 different types. Let's say that the first type is in one box, the first box, okay? the first box contains the first type of cookies. ওই box you have all the cookies of the first type, unlimited number of cookies, whatever. We're not concerned with how many cookies there are in the first box, okay? Right now, for now. The how many cookies are there of the first type. And then the second cookie type, all right, there are many number of cookies of that. The third cookie type, there are many number of cookies of that type. Fourth as well, okay? So you have to choose a certain number of cookies from each of these 4 options to finally get 6 cookies. What we are interested in is how many cookies did you choose from the first box? How many cookies did you choose for the second box? How many cookies did you choose for the third box? How many cookies did you choose for the fourth box? Okay. That is how many cookies did you choose from the first option, how many from the second, how many from the third, how many from the fourth. We don't know that number. That number could be anything. You might have chosen 2 cookies from the first option, 2 from the second, 1 from the third, 1 from the fourth. That is one possible choice, combination of choice. Let's say for the first kind is chocolate chip cookie, all right? And let's say I am the one who's choosing the cookies. So I would choose all 6 cookies from the first choice, from the first option. That is also possible. So 6 cookies from the first choice, from the first option, 6 cookies from the first option, 0 from the second, 0 from the third, 0 from the fourth. That is also possible, right?
Yes, miss.
So let's say there's one of you guys who likes chocolate chip cookies and also mint cookies at the same time. For some weird reason, you like mint cookies, okay? So let's say you chose let's say the first type of cookie is chocolate chip and the second type is mint cookies. So let's say you choose 3 chocolate chip cookies, 3 mint cookies, and 0 cookies of the third type, 0 cookies of the fourth type. That's also possible, right? So what we want to do is count all possible ways to choose 6 cookies from these 4 categories, okay? Now, if we represent the number of cookies chosen of the first type, prothom type jeta, chocolate chip cookies, for example, how many cookies of the first type were chosen? We represent that with x1. Again, remember, we're talking about the cookies that have been chosen. এই 6টা কুকির জন্য, এই 6টা কুকি pick করার জন্য, how many cookies of the first type, how many cookies of the first type did you pick? X1. We represent X4, use X1 to represent that. How many cookies did you choose of the second type? We use X2 to represent that. How many cookies did you choose of the third type? We use X3 to represent that. How many cookies did you choose of the fourth type? We use X4 to represent that. So one possibility is X1 is equal to 6. That is, you chose 6 cookies of the first type, and X2, X3, X4, all of them are zeros. Okay? So that gives us 6 cookies. Another possibility, jeta ami bollam, X1 is equal to 3, X2 is equal to 3, X3 is equal to 0, X4 is equal to 0. Okay? That is, you chose X1 is equal to 3. Mane you chose 3 cookies of the first type, X2 is equal to 3. You chose 3 cookies of the second type, X3 and X4 is equal to 0. That is, you chose 0 cookies from the third and the fourth type respectively. And that gives us 6 cookies as well. So you see, we can represent the choice of the cookies of each different type with X1, X2, X3, X4. Why X1, X2, X3, X4? That is, why do we have 4 X's here? Why do we have 4 X's here? Because there are 4 different types of cookies. Each of these different types, the choice, the number of cookies chosen from each of these different types represented with X1, X2, X3, X4, X1, X2, X3, and X4. And the total number of cookies, that you can choose is 6. So this equation represents this scenario. Does that make sense? Choosing
Yes,
6
ma'am.
cookies from 4 different categories. We can represent it using this equation. Do you see the association? Does it make sense?
Yes, miss.
Okay. In that case, counting the total number of ways to choose 6 cookies is basically counting all possible non-negative integer solutions to this problem, right? All of the x's obviously will be non-negative. The lowest value you can have is 0. That is, you didn't choose any cookie under a certain category. Let's say x4 is equal to 0. You didn't any cookies of the fourth type. That is the lowest value. Negative to kokhono hote parbe na. You cannot choose negative number of cookies. No. So let's say this is the so we use this equation to represent this scenario. So basically, the total number of non-negative integer solutions of this equation gives us the total count of all the different ways to choose 6 cookies from 4 different categories. Does it make sense? The parallel between the two, the similarity. Any questions so far?
No, miss.
Okay. If that makes sense, in that case, simply here, we know this equation. We know how to count the non-negative integer of this equation. We'll just do that. N is equal to what? For this equation, what is the value of n? Guys?
4,
4. What is the value of r?
6.
6, correct. So n plus r minus 1, that is 4 plus 6 minus 1 gives us 9. Then n minus 1, 4 minus 1 gives us 3. So NC3 will be the total number of ways to choose 6 cookies from 4 different categories. Okay, so that's how you can do it. Make sense, guys?
Yes, miss.
Okay. Now, what if, let's say, you have 3 boxes of toys, okay? So from there, let's say three types of toys. Let's say we have 3 types of toys. From there, you're allowed to choose 9 toys in total. You have 3 types of toys, 3 category of toys, and from there you can choose 9 toys in total. How would you do that? Can you tell me what it would be?
Miss the solution.
N minus 1 no, 3.
First tell me what equation will we be using to represent this problem?
Miss x1 plus x2 plus x3 equals to 9.
Exactly, correct. Yeah, why is that? Because we have 3 different categories. And x1, x2, x3, each of them represent what? The number of toys you chose from the first type, the number of toys you chose from the second type, the number of toys you chose from the third type, respectively. And the total number of toys you can choose is 9, so 9 on the right-hand side. So on that equation, if you apply the formula, what will you get, guys?
11C2.
11C2. That is n minus 1, which is 2, plus r, which is 9. So 9 plus 2 minus 1 gives us 11. Nikki, oh, is that correct? No.
9 plus 3.
Yeah, 9 plus 3 minus 1. Sorry, 9 plus 3 minus 1. 9 plus 3 minus 1 gives us 11. Yeah. So 11C2, n minus 1. Also, 11C8 would give you the same answer as well. Yeah, it would be the same thing. Again, guys, I want to remind you that I do not care about 84. I don't need to know 84. What do I need to know? I need to know NC3. Okay. So if any of you guys do not have your calculator or do not know how to calculate this or whatever, you don't need to panic. The moment you tell me that it's NC3, I know that, okay, you know how to solve this problem. Okay. I don't need to see how you calculate this. Okay. So yeah, that's correct. So think about what we are doing here. Basically, can you not say that each of these 4 x's, these are boxes? Each of these 4 are boxes, distinguishable boxes, where you're putting certain value. x1 একটা box, ওখানে তুমি একটা certain number of cookies, x2 একটা box, certain number of cookies, x3 একটা box, certain number of cookies রাখলা, x4 একটা box, certain number of cookies রাখলা. And the total gives you 6, right? Can you not think of it that way? That x1, x2, x3, x4, each of these are 4 distinguishable boxes where you put the cookies that you, let's say you take a tiffin box or whatever. There are 4 partitions there. So you take the cookies and put them in each of the 4 partitions, okay? So basically you're putting basically some stuff in each of these 4 boxes. x1, x2, x3, x4, we represent them with 4 boxes. তাহলে first box you put some cookie, second box you put some cookie, third box you put some cookie, fourth box you put some cookie, and the total number of cookies should be equal to 6. Okay. Now think about it. when they told you that you have to choose 6 cookies, 6টা কুকি যে চুজ করতে বলেছিল, তখন কি কোনো কিছু বলা আছে 6টা কুকির মধ্যে মানে what cookie should be of what type, মানে how many, like each of these 6 cookies, the 6 cookies that you choose, the 6 cookies that you have to choose, each of these 6 cookies, do you know each of these cookies are going to be of what type right at the start? Do we know? No, we don't know that. This is the process of finding out what are the different ways we can distribute these 6 cookies among these 4 boxes. All right, but right at the start we don't know. This 6 number could be distributed in so many ways among these 4 boxes. But when they said that choose 6 cookies, এই 6টা কুকি কোনটা কোন টাইপের হবে, nobody said that to you. They just told you that 4টা different type of cookies আছে, from there choose 6 cookies. এই 6টা cookies কোনটা কোন টাইপের হবে, nobody told you that. That is, these 6 cookies are indistinguishable. You cannot, these 6 cookies are indistinguishable. So this 6 number, these 6 cookies are indistinguishable. What was our task? Our task was to find out all possible ways to distribute these 6 indistinguishable cookies among these 4 boxes, among these 4 distinguishable boxes. 4টা distinguishable boxes মধ্যে 6টা indistinguishable cookie, you have to distribute them. Once you put them in the box, then they're distinguishable. They're okay, 2 of the first type, 2 of the second type, 2 of the third type, 0 of the fourth type, then they're distinguishable. But when they're in this number 6, you don't know a 6টা cookie, what are each of them, what are of which type. You know them the moment you distribute them among the boxes. Okay, so basically this is the same as counting the number of ways to put r indistinguishable objects, r indistinguishable objects, r is equal to 6, so 6 indistinguishable objects into n distinguishable boxes, into 4 distinguishable boxes. Okay, distributing 6 indistinguishable cookies into 4 distinguishable boxes is representing a type of cookie. Okay, so this is the same thing as that. So if you have a problem, any problem where you have to count the total number of ways to put r indistinguishable objects into n distinguishable boxes, you can use the same formula because it's the same thing. Okay. All right, so I had to unfortunately end it here for the last section because I couldn't continue after that point. So yeah, I'll end it here as well. If you guys have any question, I'll address that and we'll start the next session from the next point onwards. Are there any questions, guys, so far based on the stuff that we've discussed?
No, miss.
Okay, I know we haven't covered much today. We'll have to make up for that later on and cover that up later on. But like I want to keep both sections parallel. So yeah, we're not going to proceed much from here. However, I would like for you guys to think about a certain problem, a more complex problem. So let's say here in the cookie problem, similar to this, let's say I told you that you guys have to return 100 taka value, all right? And you have with you only 1 taka coins, 2 taka coins, and 5 taka coins. Is the problem clear? 100 টাকা return করতে হবে, all right? 100 টাকা return করার জন্য all you have is 1 taka coins, any number of 1 taka coins, whatever. We're not worried about that. That is not our problem. মানে you have unlimited number of 1 taka coins, let's say. কতগুলো 1 taka coin তোমার কাছে আছে is not our problem. You have some number of 2 taka coins, you have some number of 5 taka coins, all right? Unlimited number, let's say. From there, you have to return 100 taka. How many ways are there to do this?
102C.
মিস সেটাকে কনভার্ট করতে হবে।
See, the problem is not as simple as it seems at start. First, আমরা চিন্তা করতে পারি যে 1 টাকার কয়েনগুলো আমি ফার্স্ট বক্সে রাখলাম, একটা বক্সে রাখলাম, 2 টাকার কয়েনগুলো একটা বক্সে রাখলাম, 3 টাকার কয়েনগুলো 5 টাকার কয়েনগুলো আরেকটা বক্সে রাখলাম। সো 3টা ডিফারেন্ট বক্স আছে, প্রত্যেকটাতে 1 টাকার কয়েন, 2 টাকার কয়েন, 5 টাকার কয়েন আলাদা করা, অলরাইট? We can think about it that way. And আমাদের কি করতে হবে? এই প্রত্যেকটা বক্স থেকে এমন কয়েন পিক করতে হবে so that ultimately we get 100. However, think about it. We are not asking you to pick 100 coins in total. We are asking you to make up 100 taka. So if you pick 100 1 taka coin, you have 100 coins there, fine. But if you pick the 2 taka coins, in that case, it's different because the value comes as well. All right. So if one of you said that the equation will be x1 plus x2 plus x3 is equal to 100, it's not as simple as that, is it?
No, miss. এই জন্যই convert
Ma'am,
করতে হবে।
is it 98C2?
Think about it. Think about it. I'll leave some time to think about it. I want all of you guys to think about it. But first of all, what would be the equation? What would be the primary equation? First step equation ta kirokom hobe? Would it be x1 plus x2 plus x3 is equal to 11? No, it won't be. It would be actually x1 plus 2x2 plus 5x3 is equal to 11, right? Because however many coins you pick from the first box, prothom box থেকে যতগুলো coin pick করবা, which has the 1 taka coins. However many coins you pick from there, you multiply that with 1 because 1 taka coins have one value of 1, all right? However many coins you have pick from the 2 taka coin, there you have to multiply it with 2 because each coin is worth 2 there. So prottekta will be worth 2. So 2x2. However many coins you pick from the third box would be what? 5x3, okay? So does it make sense, guys?
মিস এটাকে কি আমরা নন নেগেটিভ নিয়ে যাচ্ছি? Like in the sense.
Non-negative to hobe. Mane non-negative as like okay. I mean not just non-negative. I mean non-negative e niye jacchi na ekhono. Ei je equation ta x1 2x2 5x3 is equal to 100. Here x1 x2 x3 each of them will be non-negative. Obviously you cannot pick negative number of coins. It's not possible. So x1 x2 x3 each of them will be non-negative for sure. But the problem is where? Problem ta kothay? Problem hocche ki 2 je ache x2 er sathe, that is the problem. 5 je ache x2 er sathe, that is the problem. That you have to think about. Okay? So I want all of you guys to think about it and tell me what you think about what would be the solution. So think about it. Just tweak the ideas that we've studied so far and just pick your brain a little bit, and we'll circle back in the next session to this slide and pick it from here and talk about this specific problem as well. All right. Now we'll do that from the next one. Let me just stop the recording.